This is episode 5 of the podcast, The Tech Lounge, discussing the strategic battle, data ownership versus model power.
Oh, man, I'm so ready to get into this one.
Right. I mean, we've spent, the last few years totally obsessing over how massive these AI models are getting.
Yeah.
Just focusing entirely on the algorithms and the parameter counts.
Yeah, the sheer scale of the math.
Exactly. But it turns out we've kind of been looking at the wrong thing this whole time.
We really have.
Because the real war, like the actual multi-trillion-dollar battle happening right now, is over the invisible digital exhaust. You know, the stuff you leave behind just by living your life.
Yeah, your digital footprint.
Right, like when you rode the elevator this morning or checked your fitness tracker or just tapped your credit card for coffee. So, welcome to the lounge. If you're listening, pull up a chair, grab a drink, and let's get into this deep dive.
It is the perfect conversation to have after a long day in the trenches, honestly.
It really is. Our mission today is to unpack this massive shift in the tech landscape. We're moving away from that algorithm obsession and diving straight into the really messy, highly contested world of data ownership.
It's a complete minefield right now.
Oh, a total minefield. We're talking massive copyright lawsuits blowing up the industry and this wild new frontier of data governance that developers are just frantically trying to map out.
Frantically is the right word. And if you are sitting there listening to us, you need to realize you are the actual center of this battle.
Exactly.
Like whether you are a software engineer building these systems or a project manager using them or just a person existing in the modern world generating that footprint we talked about, your data exhaust is, it's the primary fuel source for the most valuable industry on Earth.
And the evolution of that fuel source is what absolutely blows my mind. Because if you think about it, a decade ago, the entire tech industry was built around the attention economy.
Right. Getting eyeballs.
Getting eyeballs on screens, yeah. It was a race for your attention. But today, honestly, the screen time almost doesn't matter as much as the ambient data you generate while the screen is just sitting in your pocket.
Yeah, the extraction methods have completely transformed. I mean, we used to operate under this very centralized drilling model.
Like traditional oil drilling.
Exactly. A tech company would build a massive centralized database. Think of an early social media platform. And they would just drill really deep into that one specific well of user profiles.
But that's not how it works anymore.
No, not at all. The industry has shifted to something far more aggressive and, decentralized.
It's data fracking. I mean, that is the only way to describe it.
Data fracking, yeah.
Instead of a single massive, companies are fracturing the digital landscape. Yeah. They're extracting these microscopic, seemingly totally useless bits of data from billions of distributed points.
Like the temperature of your smart thermostat?
Right. Or the pressure sensors in a commercial elevator. Or, the heart rate variability on your watch. Individually, those data points are basically just dirt.
Totally useless on their own.
But when you aggregate them across millions of users, you extract the raw material for a highly capable AI. But here's the thing. The problem with fracking is figuring out who actually owns the land you're blowing up.
Which brings us to arguably the most complex ownership dilemma in modern business. Let's look at a practical example. Consider a modern MRI machine deployed in a hospital.
Okay.
So, over a period of, say, 5 years, that specific machine scans thousands of patients. The embedded AI analyzes those scans, correlates them with biopsy results, and it fundamentally learns how to identify tumors earlier.
It gets better at its job.
Right, much more accurately than it could when it rolled off the assembly line. The machine is now objectively a better diagnostic tool. So the question is, who owns that improved capability?
Man, that's such a tough question. Does the hospital own it because they bought the hardware and, paid the electricity bill?
That's one argument.
Or does the manufacturer own it because they wrote the underlying algorithm in the first place?
Oh.
Or, and this is the wild one, do the thousands of patients own it?
Yeah.
Because their actual physical bodies provided the raw material that taught the machine.
It's completely ambiguous, and private equity is watching that exact ambiguity right now. I mean, they are sitting on roughly $2.5 trillion in dry powder.
Trillion. With a T.
With a T. That is uninvested capital just waiting to be deployed. And we are seeing a massive strategic pivot happening. They are actively shifting their investments away from the generic, highly publicized generative AI models.
The ones that try to be everything to everyone.
Exactly. They're pouring that capital into highly specialized small language models, or SLMs.
Because you can't really defend a generic model.
Yeah, you can't.
But if you build a small language model trained exclusively on, say, 20 years of proprietary maritime shipping contracts.
Yeah,
You have a moat.
a massive moat.
You aren't trying to boil the ocean and compete with the big tech giants. You're just trying to cleanly monetize a specific, defensible puddle of data.
Defensibility is the absolute keyword here. When your competitive advantage is highly specific proprietary data, you do not want it ingested and diluted by a massive public model.
Which naturally brings us to the explosion happening in the courts right now. Because the concept of data fracking implies that nobody actually agrees on who owns the well.
Right.
And existing intellectual property laws are just actively buckling under the weight of this AI appetite.
They really are. We are seeing a profound collision between traditional authorship and machine capability. There was a recent landmark court decision that reaffirmed a core principle of IP law, which is that AI-generated content cannot be copyrighted.
Wait, really? It can't be at all.
Nope. The ruling centered on this concept of the human spark.
The human spark. I like that.
Yeah, so copyright legally requires human creativity. If a machine autonomously generates a text or an image, it fundamentally lacks that spark, meaning the output instantly belongs to the public domain.
Okay, but the output isn't even the main battleground anymore, is it?
Not at all.
Like, the massive lawsuits clogging up the courts right now are entirely about the input.
Exactly.
We're talking about massive coalitions of prominent newspapers, visual artists, authors, all suing the biggest tech giant on the planet.
Yeah.
And the allegation is straight up theft.
Yeah, they're not mincing words.
They are arguing that these companies scraped billions of copyrighted images and articles to build their training data sets and just completely bypassed permission and compensation.
And the tech giants, their defense is relying almost entirely on the concept of fair use.
Right.
They are trying to convince the courts that training a neural network is mechanically analogous to human learning.
Okay, break that down for me.
So they argue that they aren't taking a copyrighted book and printing counterfeit copies to sell out of the trunk of a car. They claim they are simply letting a machine read the book to understand statistical relationships.
Like grammar and style.
Exactly. Statistical relationships between words. They are arguing that machine learning is a transformative process, not a duplicative one.
I gotta say, I just can't buy that defense.
Really? Why not?
Here is why. If I sit down and read a newspaper, I learn from it. I walk away with a better understanding of the world. That is fair use.
Sure.
But if I happen to possess a flawless photographic memory, and I memorize 1 million newspapers word for word, and then I build a website where people pay me to spit out those exact articles on demand, that is piracy.
That's a great point.
Where is the line for an algorithm? Because we are seeing instances where these models are regurgitating exact paragraphs of copyrighted text, or generating images where the original artist's watermark is still visibly smeared across the bottom.
Oh yeah, the watermark thing. The presence of a watermark completely shatters the transformative defense.
Yeah, completely.
And the plaintiffs are really hammering that point home. They are arguing that the AI is directly competing in the same commercial market as the original human creators, using their own stolen labor to undercut them.
It's so messy.
The friction here is so intense that lawmakers are actually stepping in. There is serious momentum right now behind new transparency legislation that would legally force AI developers to open the black box.
They'd have to disclose the exact data sets they use for training.
Exactly.
It's fascinating because the legal system is desperately trying to govern this data from the outside, But simultaneously, corporate engineers are waking up in cold sweats, realizing they have to govern their data from the inside.
Yeah, the internal panic is real.
Because if you don't control the raw material going into your own proprietary models, you are basically actively engineering your own catastrophic failure.
That is the corporate realization happening right now. Traditional data governance is just completely obsolete in the age of AI.
It doesn't work anymore.
Not at all. We are looking at industry projections showing that by 2027, organizations that haven't curated high-quality, AI-ready data are going to suffer a massive productivity collapse.
Let's talk about why traditional governance shatters. Because in the old days, data was, well, it was polite.
Polite, I like that.
Yeah, it sat neatly in a SQL database. You had rows, you had columns, you had really clear rules.
But very orderly.
But AI feeds on unstructured and semi-structured chaos.
Yeah.
We are talking about petabytes of raw audio files, millions of security camera feeds, incredibly complex API streams, just messy text documents. Applying a traditional spreadsheet governance mindset to that, it's like trying to organize a hurricane with a filing cabinet.
And when that governance fails, you get hit with data drift.
Oh yeah, Data drift.
This is one of the most misunderstood vulnerabilities in machine learning. People think you train a model, you deploy it, and it just works forever, like a calculator.
Right, 2 plus 2 is always 4.
Exactly. But the reality is that models actively degrade over time because the real world is a moving target. The data the model encounters in production inevitably drifts away from the historical data it was trained on.
I read this crazy story about a retail prediction model that completely fell apart because of this.
Oh, the inventory one.
Yeah. They trained it during this massive economic boom. So the model learned that consumers buy premium products on a regular cadence.
Makes sense based on that data.
Right. But then an economic downturn hits. And practically overnight, human purchasing habits change. People switch to generic brands, they delay big purchases.
Well, the AI doesn't read the news.
Exactly. The AI doesn't know there's a recession. Its historical training data is suddenly totally obsolete, and it starts confidently recommending these aggressive inventory purchases that result in millions of dollars of unsold stock just sitting in warehouses.
That is a perfect example of the context gap.
The context gap.
Yeah, algorithms are brilliant at pattern matching, right? But they have zero semantic understanding of the world. They do not know why a pattern exists.
Just that does.
Exactly.
Yeah.
So to fix this, engineers are realizing they need to build systems that provide deep context. The what, the why, and the how of the data.
Because without that context, the AI agent doesn't just fail quietly, right?
No, it hallucinates. It starts fabricating information or executing highly destructive commands with total absolute confidence.
Okay, I am going to push back here a little bit.
Bring it on.
Because in the tech lounge, we hear the Silicon Valley mantra all the time. Move fast and break things.
Glass.
When I hear the words governance and semantic tagging and deep context requirements, all I hear is corporate red tape.
I get that.
If I force my developers to catalog every single piece of unstructured video data and build out end-to-end lineage tracing before they can even train a model, I am slowing my innovation to an absolute crawl. My competitors will crush me while I'm still, filling out compliance forms.
I hear that argument all the time, but that is the exact instinct that leads to the catastrophic failures we were just talking about.
Really?
Let me give you an analogy. Think about the mechanics of a Formula One car.
Okay.
Why do engineers put massive, heavy, highly complex carbon ceramic brakes on a race car? It isn't because they want the car to drive slowly.
Well, no.
They put those brakes on so the driver can confidently accelerate to 200 miles per hour, knowing they can navigate a hairpin turn without disintegrating into a concrete wall.
Okay, I see where you're going.
Data governance, specifically visibility, semantic context, access control, and tracing, those are the brakes on your AI. Unstructured data is basically a rocket engine strapped to a shopping cart.
A shopping cart.
You will move incredibly fast for about 3 seconds before you just explode.
Man, I love that. The rocket on a shopping cart.
Okay.
So we're building the brakes. We know we need visibility. We know we need context. But how do developers actually operationalize that? Like, how do you build a safe system when the real world is so relentlessly unpredictable?
You run face first into the data paradox.
The data paradox.
It is the most frustrating engineering bottleneck in the entire field right now. To build an AI system that won't fail in the chaotic real world, you desperately need real-world deployment data to understand all the bizarre edge cases.
Yeah.
But you cannot safely deploy an untested system into the real world to gather that data without risking a total disaster.
It's the ultimate catch-22. I mean, it is literally like trying to build an airplane while you are currently falling out of the sky.
That's exactly it.
You need the aerodynamic data of the fall to know how to design the wings, but if you don't already have the wings, you're going to hit the ground. How do they actually solve that without crashing?
The mechanism they use is proxy data, combined with iteratively expanding scope.
Proxy data.
Yeah, they don't just dump the AI into the wild. They simulate the real world in a highly restricted lab environment using proxy data. Then, they crack the door open just a fraction.
Like a beta test.
Sort of, deploying it to a tiny, strictly controlled segment of users to gather real data. But to do this without bias, you actually have to restructure your entire engineering department into 4 distinct units.
Right, I've seen this. You need the product team deciding the business goal, you have the data team acquiring the fuel, the solution team actually writing the neural network, And then most crucially, the verification team.
And the physical and operational separation between the solution team and the verification team has to be absolute.
It has to be a total wall.
Non-negotiable. Because if the engineers building the model know exactly what data the verification team is going to use to test it, human nature takes over.
They will cheat the test.
Exactly.
Even subconsciously. It's like giving a high school student the exact answer key for the final exam. They won't bother learning the underlying subject. They will just memorize the answers.
Dot on.
The developers will optimize the model to perform flawlessly on the specific evaluation dataset, which just creates a fragile AI that shatters the moment it encounters something new.
Which is exactly why we have to talk about the different flavors of data. You can't just throw a petabyte of text at a wall and hope for the best.
Right.
You need engineering data to build the foundation, evaluation data for the verification team to test it, and then you need the hardest materials to acquire: scope data and edge case data.
Scope and edge case data.
This is the data that represents the weird, chaotic reality of human existence.
And when a company gets arrogant and ignores scope and edge case data, the fallout is wild.
Oh, it's terrible.
Take that prominent real estate pricing algorithm that made headlines recently.
Oh, the one that tanked the division.
Yes, it was designed to automate home buying, but it systematically overpaid for thousands of houses, losing the company an absolute fortune.
And why did it fail?
Because the model only had spreadsheet data. Square footage, zip code, number of bathrooms. It totally lacked the scope data that a human agent absorbs instantly.
Right.
A human walks into a house and smells terrible water damage, or notices the neighbor's yard is literally a junkyard. The AI didn't have the scope to perceive that, assumed the house was pristine based on the spreadsheet, and just overpaid.
And the stakes get much, much higher when you move from financial algorithms to physical navigation.
For sure.
Look at the disaster in Los Angeles with that major routing app. A massive wildfire breaks out. The highways are gridlocked with people trying to evacuate.
A nightmare scenario.
Right. The AI routing system looks at the map, sees that the local roads leading directly into the burning mountains have zero traffic, and starts aggressively routing escaping drivers straight into the active fire zone.
Unbelievable. All because extreme, rapid onset natural disasters weren't adequately represented in its edge case training data. It just saw an empty road and optimized for speed.
Exactly.
This is why the entire industry is trying to adopt continuous assurance. Like in traditional software development, we have CI/CD pipelines, right? Continuous integration and deployment. You push an update, it's tested, it goes live.
Standard practice.
But with AI, you need continuous assurance for the data itself. You cannot test a model, deploy it, and just walk away. Accents change, slang evolves, economies crash. The model has to be relentlessly audited against new data in real time.
It is the only way to catch hallucinations before they reach the end user. But let's zoom out from the corporate level for a second.
Okay, let's zoom out.
We've been talking about companies protecting themselves from bad data. The conversation gets significantly darker when we look at frontier models.
The really big ones.
Yeah, systems powerful enough to potentially synthesize novel chemical compounds or automate massive cyber attacks. At that level, the data they consume isn't just a corporate liability, it is a global security threat.
And governing data at a global scale feels impossible because data breaks all the rules of physical physics.
It really does.
Like, if you want to regulate uranium, you put armed guards around the mine because uranium is rivalrous. If I have a chunk of it, you can't have it.
Right.
But data is non-rival. We can both use the exact same data set at the exact same time. It's also non-excludable. Once it leaks onto the internet, you can't put the toothpaste back in the tube. And it is infinitely replicable for essentially zero cost.
And because traditional regulation fails there, researchers are developing a completely new architecture for frontier data governance.
I'm intrigued.
Think of it as the fence-in-depth strategy against a rogue actor trying to build a dangerous AI.
I love this framing. Walk me through it. Let's say I'm a malicious actor and I want to train a model on highly classified, dangerous materials. Let's say bioweapons.
Okay, step one. You try to simply buy massive amounts of sensitive data from a broker. To stop you, regulators are proposing banking-style KYC laws. Know your customer.
Like when I open a bank account.
Exactly. Just like a bank has to verify your identity to prevent money laundering, a massive data broker would be legally required to verify exactly who is buying a petabyte of training data, ensuring it isn't a shell company for a rogue state.
Okay, so I can't buy it. Step two, I decide to steal it.
That triggers model data security. Right now, tech companies put military-grade encryption on the final AI model, but they leave the raw training data sitting in relatively vulnerable cloud buckets.
Which is crazy.
It is. This new protocol mandates treating the training data with the exact same cryptographic paranoia as the final algorithm.
Fine, I can't buy it, and I can't hack the secure servers. So I resort to scraping the open web, vacuuming up every piece of copyrighted and sensitive material I can find to train my model in secret.
And that is where you trip a Canary token.
A Canary token.
This is brilliant. Data producers actively embed invisible digital tripwires inside their images or text. It might be a mathematically altered pixel pattern or a syntactically unique, totally nonsensical phrase buried deep in a document.
Okay.
When your rogue AI ingests that scraped data, it unknowingly absorbs the tripwire into its neural weights. Later, a regulator can query your model with a specific prompt, trigger the hidden canary, and mathematically prove you trained on stolen or prohibited data.
That is the ultimate trap. It completely reminds me of the old cartographers who used to draw fake paper towns on their maps.
Yes, exactly.
If a competitor published a map with that exact same fake town, you knew they plagiarized you. Canary tokens are paper towns for the algorithmic age.
They really are.
But what if I somehow bypass the tokens?
Well, before you even begin training, you'd face mandatory data filtering. This legally requires developers to run their datasets through automated scrubbing systems, specifically designed to identify and purge highly dangerous content-like instructions for synthesizing those bioweapons before the model ever sees it.
Wow.
And finally, you are subjected to mandatory reporting. You have to open your books to a third-party government auditor who inspects your pre-training data diet. No more hiding behind a proprietary black box.
So it's an entire gauntlet. You have KYC to stop the purchase, model security to stop the theft, Canary tokens to catch the scraping, filtering to scrub the danger, and reporting to audit the whole thing.
Exactly.
It is a massive shift from regulating the output to aggressively securing the supply chain of the input.
That's the paradigm shift. And the most critical takeaway for you listening to this right now is that you are the origin point of that supply chain.
Yeah, you are.
Every time you log a run, click an article, or scan a badge, you are generating the foundational asset of the 21st century.
Let's bring this all together. We started by mapping the shift from the attention economy to the era of data fracking. We dug into the collapsing fair use defense in the copyright wars. We went inside the corporate panic over unstructured data, the context gap, and the absolute necessity of continuous assurance.
It's a lot of ground.
And we ended by looking at the radical new mechanisms designed to govern the frontier of global data security.
Before we wrap up, though, there is one final reality we really need to confront.
Lay it on me.
We spend all this time arguing about how to govern human-generated data, right? But researchers are looking at the ingestion rates of these massive models, and they're realizing something terrifying.
What's that?
We might actually run out of high-quality, human-generated public text somewhere between 2026 and 2032.
Wait, run out?
The well is going to run completely dry.
Oh, wow. Which means to keep improving, AI companies will have to pivot to synthetic data, training their new models on the output generated by older models.
Exactly.
If we are struggling this hard to govern the context, copyright, and safety of data when human beings are the ones creating it, how on earth are we going to govern it when the machines are simply talking to themselves in the dark?
It fundamentally changes the nature of the data paradox. Because when the exhaust of one algorithm becomes the fuel for the next, any hallucination or bias gets amplified exponentially. It becomes a compounding loop of synthetic reality.
Man, that is definitely something to keep you up at night the next time you ask your phone to summarize an email.
For sure.
Thank you for hanging out with us in the lounge for this deep dive. The next time you tap your card or walk past a smart sensor, remember, you aren't just living your life. You're actively depositing tiny drops of fuel into the engine that is rewriting our reality. Have a great night.